Let's quickly go through your packet and make sure that you had everything right. First of all, I've highlighted in orange which page you should be turned to on each of these. So on the quiz, make sure you look for the keywords and find the correct page. Mid-segments are always half the length of the side that's opposite. Since E is a midpoint, that's how we make a mid-segment, those two would be equal. On these, you should know that each mid-segment is parallel to the side that it's not joined to. As far as like 7, 8, and 9, the congruent pieces, well, for YJ, we know that J is a midpoint, so JX would definitely be congruent, but also LK is going to be half of that length, so LK's length should be the same as all three of those. On the perpendicular bisectors page, right here I highlighted the 3 perpendicular bisectors. What's cool about that circumcenter is that it's the same distance to each vertex. So the 9, the 9, and the 9 are all the same. D is a midpoint, so those are both 6. And for side FA, you had to use the Pythagorean theorem on that little shaded triangle. So I got the square root of 72 for that length. On the second one, right here are my perpendicular bisectors. Again, that circumcenter is the same distance to each vertex, so that's 11. D would have to be a midpoint, so those are both 7. On the next one, first you were supposed to draw this. Use your ruler to find those midpoints. And if you didn't come out with a point somewhere near 7, 7, it could be that either you measured your midpoint wrong or those aren't perfect 90-degree angles. Remember, we're using a note card or a protractor or whatever to make sure that perpendicular really means perpendicular. You have to be accurate. On the in-center page, that was about angle bisectors, and if the in-center has to be equidistant to each side. So since this one was 9, that one is 9. On this one, we didn't know LH, LF, or LK, but we could find LK with the Pythagorean theorem. Once we knew that LK was 8, then we know that HL is 8. Number 14, we should have been looking for an in-center to be equidistant to each side. So I found 3 angle bisectors. I even drew in the circle to show that that fountain would fit right in there with the in-center as the middle. Next page, the centroid. So here is the midpoint formula. And I just calculated the midpoint, x plus x divided by 2, y plus y divided by 2. And when I graphed those, I was pretty convinced that those 3 points looked like midpoints. Since I was making a centroid, I was on the centroid page, I connected each midpoint to the opposite vertex, and that centroid wound up being at the point 5, 1. Still on that centroid page, because we know that the centroid is the balancing point. Again, I drew the angle bisectors. Oh, that's not what I meant. Not the angle bisectors. For the centroid, we're drawing the medians. I'm sorry. So you're on the medians page. So midpoints to opposite vertex. Midpoints to opposite vertex. Same thing here. Midpoint to vertex. Midpoint to vertex. Midpoint to vertex. I didn't need a protractor at all on those. Point B was the balancing point. For this one, it helped to still be on that centroid page. And what I was looking at is these helpful measurements we put here. Remember how that's twice as long as that, and that's twice as long as that. So on this one, that's the idea that I was using. This one's twice as long as that. And down at the bottom here, we had D as a midpoint, so that was helpful, and we also had a nice right angle, which actually technically makes all 4 of those. Segment DB could be considered all 4 of those. Angle bisector, the toughest to think about, but I figured that these separate triangles were congruent by side, angle, side, so that means that all their parts are congruent, so this must be a bisector of angle B down there. This one is just an altitude. If you imagine dropping the watermelon straight down. And this one is a median, where you find the midpoint, tick, tick, and connect to the opposite vertex. 19 through 22 would be super easy to do if you have everything filled out in your purple book, because you just turn to the Centroid page. Was it always in the triangles, whether it was acute, obtuse, or right? Yes, it was. Always, always, sometimes, sometimes. There's no proof on the quiz, but this is part of our standards, is to look at a proof of the mid-segment theorem. So I just wanted you to try your best. Using the midpoint formula is a little awkward because we had letters instead of numbers, but I got my midpoints to be QR and Q plus PR. Both of those slopes were 0, which means the lines were parallel, so that proved that part of the mid-segment theorem. And then when we found the lengths, this one was 2p long. This one was a little tougher. We had to figure out how far that was, and I figured that it must be 1p long. So 1p versus 2p means that we've got side DE being half of side OC's length. Circumcenter is perpendicular bisectors. In center is angle bisectors. You didn't actually have to draw those, but what you did have to draw was the circles. So we say that this circle circumscribes because it's equidistant to each vertex. And this one is a circle on the inside because it's equidistant to each side.